Okay, so we're going to do sketching quadratics in 5 minutes tops. So I've got the function f of x, which means y, don't forget, is x squared minus 12x plus 20. We know it's a quadratic because the highest power of x is this x squared there, making it quadratic. So if I'm sketching this, I'm going to want to know my y-intercept, my x-intercept, and we also know it's a quadratic, so it's going to have two x-intercepts, two roots. And with a quadratic, I especially want to know the turning point. At the moment, that's kind of almost like a bonus thing probably in your brain. But when we get into modelling with quadratics, the turning point becomes one of the most interesting points on that function. And so it's really, really important that at this stage you get really good at working out how to find it. Okay, so to find that y-intercept, I'm asking, where does the function cross the y-axis? Well, here's our y-axis. This is actually the point, all of the points in fact, where x is 0. Think about your x-axis, you've got large positive numbers over on this side, and then you get smaller and smaller and smaller and smaller. You go through 0 on the line, and then you go into negative. Now that might be very, very, very obvious to you, but it's really worth thinking about in this way. The line y, the y-intercept rather, is the line x equals 0. It's all the points where x is 0. So to find where something crosses that line, I need to make x 0. So I'm going to notate this f of 0. So here, the x has become 0, which is exactly what we said we needed to do. We needed to make x 0. So that's a really nice way of notating it, and that should give us 0 squared minus 12 lots of 0 plus 20, and so f of 0, the y-intercept, is 20. So I know now that that's the point 0, 20, which is good. Something like here, for instance. For the x-intercepts, I'm doing the kind of opposite thing, if you like. I'm now asking, where is it crossing the x-axis? Well, the x-axis is all the points where y is 0. The kind of converse argument there. So I'm now needing to make y 0. Well, y in my equation is represented by f of x. So to find my x-intercepts, I need to make f of x equal 0. So that gives me 0 equals x squared minus 12x plus 20. Now I've got a quadratic that's equal to 0, so I can factorise this and solve it, but I can only solve it because it is equal to 0. So I must keep that equals 0 going there. So I'm going to write that in first, and I can actually factorise this. It might not always be possible. Just because it isn't factorisable doesn't mean that it isn't solvable. You've got all sorts of other methods. So we'll just factorise. There we go. That gives me x equals 2 and x equals 10. 2 points here, 2 and 10. And I should now, good luck, be able to sketch out this function. In fact, you know what, I would always recommend sketching the quadratic in the right area and then putting your points on, because as you can see, it's worked out very poorly there. So there's my 2, there's my 10, and there's 20. As long as they're in the right places, you could then mark on those actual crossing points later on. To find the turning point, we're going to need to complete the square, and hopefully that is something that's familiar to you. So x minus 6, I'm just going to do it, x minus 6 all squared minus 6 squared plus 20 gives me x minus 6 all squared minus 36 at 20, and last line, x minus 6 squared minus 16. And this is still the function f of x. I haven't solved, I haven't substituted, I'm just manipulating the algebra. There is a link for the completing the square to graph transformations, which is something we're coming on to very soon. There's a video later down the website for that. But we're just going to sort of read the information off of this for now and then go and check out that video to know why. So here I've got an x value, coordinate value of 6. So that kind of makes sense, there's 6 there. And a y coordinate value of minus 16. Now, incidentally, if I was to solve this equation equal to 0, bonus fact, I would get the same 2 roots that I had before, because obviously solving any function equal to 0 will give you where it crosses the x-axis. So it should come out as 2 and 10. Done.